Hello guys, in this tutorial I'm going to solve question number 11, winter 20, variant 2. By looking at question number 11 and this function, it's a trigonometric function. So it's better to revise about graph of cosine because it's included cosine. You have to recognize the graph of cosine started from 0 and 2 pi, but maybe I will change the range. If it is 2 pi, so in the middle pi, fourth distance pi over 2, and 3 pi over 2, or you can change the range. Started from 0, 1, 0, minus 1, 0, and 1. All of you have to recognize this graph. Then we'll start to use transformation. What about cosine 2x? Cosine 2x means two waves from 0 to 360. Two waves from 0 to 360. You will get, if you reduce the interval from 0 to pi over 2 to be pi over 4, you will get again 1, 0, minus 1, 0, and 1. Then repeat again 1, 0, minus 1, 0, you will get two waves. I will show that accurate curve started from, I will explain cosine x, then cosine 2x, then 3 cosine 2x, finally 3 cosine 2x plus 2 to revise for transformation of the graph of cosine. As we know, cosine x from 0 to 2 pi, but I will back again to the question and use it only from 0 to pi. But in general, I will explain the curve from 0 to 2 pi. This is number one. This is the graph of cosine x only from 0 to pi over 2. Look at the curve. Start from 1, 0, minus 1, 0, 1. What is the maximum value for the cosine x? The maximum value is 1. What is the minimum? Negative 1. This called the range of cosine x from negative 1 to positive 1. This is the minimum value. Start the curve from y, negative 1 to 1. This is the curve of cosine x. If I ask to sketch the curve only from 0 to pi, so you have to follow from 0 to pi, but still the range from negative 1 to positive 1. You can extend the curve to the left-hand side by this way. This function is called a periodic function because it started to repeat itself after 2 pi. This is the graph of cosine x. What about cosine 2x? Will be same curve, but the curve repeat itself after pi. You will get two waves. Start from 1, then 0, minus 1, 0, and 1. You will get the curve like this. This is the first wave. Repeat again 1, 0, minus 1, 0, and 1. You will get another two waves, and so on if it is 3. I will show you now the accurate curve for cosine 2x, then discuss about the minimum and maximum. This is the curve of cosine 2x. See, start from 1, 0, minus 1, 0, 1. This is the first wave. Repeat 1, 0, minus 1, 0, 1. This is the second wave. Exactly. If we now ask about the range, it's still from negative 1 to positive 1. So what is the minimum and what is the maximum value of cosine 2x from negative 1 to positive 1? I explained from 0 to 2 pi. So if it is from 0 to pi, still same, from negative 1 to positive 1, the maximum and minimum. So 2x, if we ask about this transformation it's called stretch with x-axis horizontally, and the scale factor, do you remember scale factor means half. For x-axis we change, find the reciprocal. So when I ask to describe this transformation, stretch, parallel to x-axis, scale factor half. This means we multiply the x coordinates of the function by half. If you remember, when we started to sketch the graph of this function, forming a table, and this table starts from 0 to 360. Maybe this is the first time to sketch the graph of any function. We can use this method. Start from x and y. I explain it where is x between 0 and 360 if it is given in degrees. If it is in rad, will be 2 pi. Start from 0, then pi over 2, then pi, 3 pi over 2, then 2 pi. You will get 1, 0, minus 1, 0, and 1. How to show this stretch? Cosine 2x, multiply x by half. You will get 0, 1. Multiply by half, pi over 4 and 0. Multiply by half, pi over 2 and minus 1. Multiply by half, multiply by half. You will get the first period. Continue to the second one. This is the description. If I ask about this stretch, horizontally, parallel to x-axis, scale factor half. The next step, if it is 3 cosine 2x, 3 cosine 2x, when you multiply the function by 3, this is called stretch. Parallel to y-axis, scale factor is 3. We stretch the function from -1 to +1, becomes from -3 to +3. So the graph of this function will be 1, 0, minus 1, 0, 1. Continue, 1, 0, minus 3, 0, and 3. So now, what is the range of this function? Algebraically, cosine 2x, it's included between -1 and +1. If you multiply it by 3, will be 3 cosine 2x greater than or equal to -3, less than or equal to 3. So now, what is the range of this function from -3 to +3? Again, I explained this point from 0 to 2 pi. By looking at the question, he asked to identify it from 0 to pi, still same, from -3 to +3. The third step, after graph 3 cosine 2x, we explain started from cosine x, then cosine 2x, then 3 cosine 2x. The last part, if you look at the curve, it's written +2. +2, this called translation up, will take the curve and move up how many units? 2 units. If you take it up and go 2 units, so the minimum from -1 up to 5. See the next graph. If we take the curve and move up, we move graphically from -3 to up -1. This is the minimum. And the maximum now is 5. This is the final range of the given function. We'll explain it again, the range algebraically. I started with cosine x between -1 and 1. Cosine 2x, still from -1 to +1. Don't say it's from 2 to -2. There is no change for the domain when we stretch x or parallel to x. Stretch for y now will change to be from -3 to +3. Translation, 3 cosine 2x by adding 2 for both sides. If you add 2, will be -1. If you add 2, will be 5. This is the final answer for the range. The range, the values of y from -1 to +5, if I ask what is the range of this function. Now, after explaining graph of sine, cosine x, cosine 2x, 3 cosine x plus 2, description, what is the difference between translation horizontally, translation vertically, stretch horizontally, stretch vertically. Now, let us start to solve question number 11, part A. State the greatest and the least value of y. For me, I prefer to sketch the graph first on the given domain. To know the values of y, start from end with. See, he switched between part A and part B. For me, I prefer to sketch the graph first to know the minimum and to know the maximum. But I already explained it algebraically. You can get it mentally by removing cosine 2x. Cosine 2x, the minimum value is -1 and the maximum value is +1. So we can remove cosine x and write -1. So -1 will be -3 plus 2 is -1. If we substitute by 1, so the answer is 5. So what is the minimum? What is the maximum? The greatest value is 5. The greatest is for y is 5. And the least is -1. It's clear from the curve, or by using substitute by -1 and +1, or by starting algebraically as I explained, cosine x between -1 and 1, cosine 2x between -1 and 1, multiply by 3 from -3 to +3, by adding 2 will be 5 and -1. We also explained this part. Sketch the graph of y equal 3 cosine 2x plus 2, where is x between 0 and pi. Or I will use a table, but I explained by using the transformation. You can use your calculator for this table, but follow the domain which is given from x to y. He asked to sketch it from 0. It's better to use pi over 4, then pi over 2, then 3 pi over 4, then only pi. You can reduce to take it pi over 8, pi over 4. If we try to use the calculator now by using mod 7 to form a table, use red system, start, write the function 3, then cosine 2x plus 2. The start from 0, the end is pi, the step is pi over 4, pi over 4. You will get the points 5, 2, -1, 5, 2, -1, 2, and 5. By plotting the points, you will get the curve. I will show only the curve from 0 to pi. See, this is only the curve from 0 to pi. Start from 5, -1, and end with 5. This is the graph of the function from 0 to pi. By considering the straight line y is equal to kx. I will show the graph only for this part. Let's now read part 2 after sketching the graph. By drawing a straight line, y is equal to kx. Solving equations graphically, it's depend on sketch the graph of the left-hand side, which we already have it, and draw the graph of the right side. So write the function y is equal to kx. This function is a straight line. Where is k is equal to -3? If we remove x and write -3. By sketching this line, try to use the range 0, pi over 2, pi, 3 pi over 2, 2 pi to sketch this line. If we draw box, just I need only 2 points from 0, then pi over 2. If you substitute by 0, you will get 0. If you substitute by pi over 2, you will get -3 pi over 2. If we try to calculate this value as a decimal, it's a -3 pi divided by 2. It's about negative 4.7. If we substitute by pi, negative 3 times pi, it's approximately negative 9.4. Pi over 2 is approximately negative 4.7. If we try to show the line on the graph 0, 0, 0, 0, if you substitute by pi over 2, you will get this value. As I told you, it's negative 4.7. By joining the line, is the line cut the curve at any point? No. So when I ask you to solve this equation graphically and give the number of solution, state the number of solution. So the first one, no solution, so 0 solution. You can write no solution or 0 solution. The next one, where is k is equal to 1? We'll try to sketch the line y is equal to x. By the same way, we need at least 2 points, x and y. If we substitute by 0 and pi, or pi over 2, or both pi over 2 and pi. Substitute by 0, you will get 0. Substitute by pi over 2, you will get pi over 2. It's a decimal. It's approximately, when you write pi divided by 2, approximately 1.57 or 1.6. If you substitute pi, you will get pi 3.142. Now, if we plot the points of the straight line, I will show that will be how many intersections. After drawing the line y is equal to x, I will show what is the relation now between the line and the curve. See, after drawing this line, I need just only 2 points from 0, 0 and just pi. Plot the points, you will find the curve and the line cut at 2 points. So how many solutions for this case? There are 2 solutions. The third case, when substitute by k is equal to 3, by the same way, draw a line. By drawing the line, use rad x and y. Substitute by 0, pi over 2, and pi, plot the points, draw the curve, draw the line, cut the curve from 0 to pi only at only 1 point, so there is only 1 solution. So this case, there are 2 solutions, and this case, only 1 solution. Part D, it's given a function f, which is up, g and h are defined by, where is x belong to r. F of x given, g of x, h of x. Describe a fully sequence of transformation that map the graph of y equals f of x onto g of x. Now look at g of x. It's f2x. We replace x with 2x. When you replace x with 2x, this is called what? Stretch. This is stretch. Scale factor what? Scale factor. Don't forget, for x, we find the reciprocal. So the scale factor is half. This stretch parallel to x or parallel to y? It's parallel to x axis. We can write in direction of x-axis. We can write horizontally. We can write in direction of x-axis, and we can write horizontally. This is part D. Describe fully a sequence of transformation that maps graph of y equals f of x to the graph of g of x. This is the first part of the transformation, followed by, when we add 4, this is called what? Translation. This translation parallel to x or parallel to y. Translation. we can explain the translation by the vector. Move up 4 units, so the vector will be 0, 4. So the final answer, stretch, scale factor half, parallel to x-axis, followed by translation is given vector 0 and 4. Part E, describe a fully sequenced transformation map F to H. Now look at to H. First, we change x to be x plus half pi. This called what? Translation. But this translation, right or left? Left. Don't forget, for translation with x, we change the sign from positive to negative or from negative to positive. So this translation with a vector what? Negative half pi and 0. Followed by this 2 represent what? Stretch. This stretch parallel to y-axis vertically with a scale factor 2. So now we'll describe these two transformation. The first one, translation. This translation by vector negative pi over 2 and 0, followed by stretch. And this stretch scale factor 2 and parallel to y-axis. We can write in direction of x-axis or we can write vertically. That's it.